Okay, we'll get started when everyone's settled, found their way to the pizza. Good, good.
You're going to start sooner? I thought 6 o'clock, right?
Sorry?
6 o'clock you're going to start, right?
No, so 5:30, but then we wait a bit for people to let me check.
Because the schedule that I saw was like 6:05 is when I go.
Oh, hang on, let me do this. Yeah, okay. So we've put welcome networking registration. So yeah, actually in that in that case, we'll wait until 6.
I don't mind going early, but
well, it's I think people probably won't come until
that's what
6.
I was thinking.
Yeah,
that's what I was thinking.
Yeah.
Can you hold on to this for a second?
Yeah, sure.
Back again.
Yep, sort of go in that direction, and then it's behind that gray wall at the back. Hey, Rob. So Dinesh pointed out very correctly, the schedule actually says we'll start talking at 6. So maybe like we'll wait a bit so people might not actually come until 6 o'clock. Wouldn't want them to miss out, so. Yeah, no, I'm afraid not. Do you want to charge something? Well, I have we've got that's what we're using. So we're running like an extension lead from there.
I'm just running a bunch of containers, and either I take the time to start them up again, or I plug it in.
Yeah. Would you want to like plug it in and sort of leave it, or up to you?
That's probably going to work out best.
So feel free, like if you want to leave it on the chair, for example.
We're demo running.
Fantastic. That's what I like to see. Yeah, I think we found like demos work really well we have like a mix of like, presentations, demos.
It's pretty.
Yeah. Yeah, so looked at the schedule again. We're actually getting started at 6. So yeah, it's just like a bit of
So you're
time.
the first.
No, I'm sorry. I'm not speaking this time.
Oh yeah.
I've given you my slot.
Yeah. So I'm the first speaker.
I put you like I sort of like sandwiched you in between.
Okay.
So
Second one.
yeah. So
Each one is like 25 minutes.
Yeah. And yeah, some people told me like they're excited to hear what the next version has in store.
My part is I would say it's a little bit technical. We're trying to like skip all the technical part.
Yeah.
It's like since I really want to do the comparison between Milvus and Elastic, so it's gonna be not really AI, but a lot of like search stuff.
Yeah.
So let's see. Yeah, I try to see like how people act.
Well, I'm sure it'll go really well, and I guess yeah, you can use like the feedback for next week as well. So we're actually going to get started at 6. So if you haven't introduced yourself to your neighbor, this might be a good time to turn around and have a chat. Yep.
So because usually people come at the end when it takes me time to enter everyone.
Yep.
So just do it now.
Okay.
We're also telling people when they come in
Okay.
to register.
One important announcement before we get started. So we've got like a raffle competition. If you want to enter the raffle to win some really cool swag, click or go to the QR link, fill out the form, and give Milvus a star. Some pretty sweet swag. Also, don't be shy to sit in the front row. I see everyone's kind of like avoided the front row.
It's like a guard, man. Line of defense.
Yeah. It's like when you're at the, I don't know, baseball field and you got the little sort of barrier from the pitch.
That's right.
We may also be overflowing with the seats. So if you can't find a seat, check out the sofa lounges on the sides. For those of you who just walked in, if you want to enter a raffle to win some really cool swag, check out the QR code there and fill in the form and give us a star on GitHub. Yeah, people are scared. That's good that you weren't afraid of the speakers by sitting in the front row.
Oh, this for speakers?
Oh no. I was just sort of noting like no one else sat in the front row because maybe they were scared of being so close.
I mean, she told me.
Yeah, no, that's a good place. You got front row.
You was this
Yes, yeah. So I'm a developer advocate.
developer advocate?
Yeah.
Oh, nice.
And hosted these unstructured data meetups, which we do 2 a month, as well as like one in Berlin, and we have been doing like one in New York as well. How about yourself? What do you do?
So I have a low-code platform. Low-code, no-code platform.
Yep.
That helps you to create an application within minutes.
Okay. So that's what like connects you to all the like GPUs and stuff behind the scenes to.
That's that.
So it gives you access to GPUs behind the scenes so that.
It's a like mobile or web application if you want to build a mobile or web application.
Oh, okay, not like generative AI. Hi.
I think your person has asked you to get it. You are the developer advocate for this.
Yep, that's correct.
So I was tinkering in my startup, like using ChromaDB.
Yep.
So I would like to get in touch with you.
Yeah, absolutely.
sometime like this week.
Yeah,
I
sure.
want to get some hands-on experience. How to
Yep.
use Milvus. So what is the way to reach out?
So the best way is via LinkedIn. So I'll give you my.
Okay, I'll give. Why don't you connect to me?
Sorry. What's your name?
Oh, my name is Peter. Can you speak? I'm part of Volta, like secure multi-cloud network.
Okay. Yeah. Cool.
So yeah, so we built like LLM as a part, as a service. So ChromaDB, but I think you're saying why you guys use ChromaDB. Who is the
If you want
person?
to, if you want to like be able to scale in the future.
So that's why like when is the best time to?
So just send me a message. Tonight, tomorrow, and then we'll find a time. Maybe Friday could be possible. Yep.
And then I can download and play around maybe in the afternoon.
Yep. Sounds good.
Yeah, how much time it takes?
We could just sort of start with like an intro call, just see like so I can understand like what you guys are building, what like the obstacles you're having are, how you're using.
So do you use like do you have like use case where like integrating with line change with
Yes, yeah, we've got a lot of material on integrating with.
so that I can
This one.
Yeah,
This one
sure.
is,
So yes, I think
compass.
we're about to get started. So send me a message and
Same thing.
no, so we've got quite a few people from Zilla.
Records, not
Look out
records,
for
like
people with
transcribes.
Zilla.
convos.
So for example, we've got James here, engineer. We've got
I'm
Brett
sure it
and
goes to the
Adam and
internet somewhere,
Sachi
but you
at the
know,
desk over there.
transcribes to my phone is what it does.
So like a mix of like sales, engineering.
Bluetooth. I have to have my app.
relations.
on.
Hey, Dinesh.
Yeah.
Oh, I see you got it mic'd up. Just make sure the this bit is sort of facing up so that you get a really good signal.
Which bit?
So that's the microphone
Okay.
in the middle there. So you happy if I get started and introduce him?
Yeah.
Yeah.
AI background, or sometimes like because
Why both the be
Sorry.
why here?
Well, it's it'd be quite hard to like find the right venue.
Where is your office?
It's in Redwood Shores.
Plug and play?
Sorry,
Plug and play?
plug and play. Oh, is that like a open space for?
If you ask them, maybe you'll get it.
Yeah, no, we're definitely open to like suggestions of places like for the South Bay in particular. Like we typically use the GitHub offices in San Francisco for that one.
Hacker Dojo or plug and play.
Yeah. Yeah, have a chat to Sachi in the black top at the table. She'd love to hear. Yeah. Okay, because yeah, I think yeah, we're also like not so familiar with like every single venue, so maybe there's one that we don't know about that would work really well. So, okay.
This is an older laptop, so the Zoom needs to update. I apologize.
That's okay. We'll get started in a few minutes, folks. Just wait for everyone to trickle in, settle down, find their way to the pizza.
Is that the LinkedIn?
Yes, yeah. You think like, what if you canceled the update? Do you think that would? Because I mean, with the Wi-Fi, it looks like it's a pretty weak signal. So I'll
Bad now, sorry.
well, it's okay. Yeah, sure. We could do you think this would take more than 5 minutes?
Don't know.
Don't know. Let me see if James would be happy.
Sorry.
That's okay. Hey James, would you actually how would you feel about going first actually?
Yeah.
We're having some tech. Okay, sounds good. I'll just grab the lavalier.
Are we swapping?
Yeah. So we'll put you second. Sorry. Can I just mic you up? So that's the microphone there. And put it as close as you can, like maybe sort of your collar around here, or maybe even like your t-shirt. Sort of pointing straight up. Got it. Okay, excellent. Well, I'm going to talk for a few minutes, so
Sure.
be fine. Hi, everyone. Are we ready to get started? Let's do it. So I wanted to start off by introducing myself. So I'm Stefan, developer advocate with Zillits. And as a developer advocate, it's my role to like bridge the divide between developers and end users. So I really love chatting with you folks about like, what are you building? What sort of like challenges, exciting, things you've discovered. So really encourage you to reach out. I've got a QR code to my LinkedIn. So feel free, send me a LinkedIn message, email, Twitter, also active there. Would love to hear from you. So before we get started, I just wanted to ask a few questions. So how many people are from industry here? Raise your hand. How many people are students? How many people have heard of vector databases before? And how many have heard of Milvus? So yeah, great to see a lot of hands there. So by the end of the night, you should have a really good sort of grasp of like, what is Milvus? What can it do for you? But let me introduce the three speakers. Oh, and so if you want to check it out while we're just sort of getting set up, scan one of these QR codes here and I'll take you to the site. Okay, really excited to introduce our three speakers for tonight. So we have Dinesh, James, and Rob talking about some really, I think, sort of like quite varied aspects of generative AI infrastructure. So we're actually going to start off with James. So James is VP of Engineering at Zillitz with us, and he's going to be talking about the next version or the coming release of Milvus. And some of the like really exciting new features. So let's give it up for James.
Can you just show me the Zoom link?
The Zoom link. Sachi?
Okay, could you just send me the Zoom link? Yeah, but just give me us 1 moment. I just need the Zoom link.
And then make sure you speak into this mic.
Oh, just microphone.
Yep.
Thanks everyone. So before we've been waiting for like our so today on my topic will be hybrid search. How the next step for Milvus 2.5. I think the major progress is about how we do hybrid search. So just give me one.
Just share. Okay, so I just request sharing. I need to be.
Okay, and now.
Do I need to enable audio?
No.
No.
Do you want to share your screen? Have you shared your screen from the Zoom app? Yep. Okay, now we're good. So now if you go across to Keynote and make it full screen. Yeah. Oh, sorry, I have to make it.
So quick introduction about myself. So James, VP of Engineering as well as I also built Milvus from scratch, like back to 3-4 years ago. So we are kind of like the most scalable performance RapidDB solution in the market as well. We are open source. So I before joining Milvus, I actually worked from a couple of different databases from Oracle, and I joined Alibaba Cloud as like database designer.
James,
Do you want me to put up at all?
Yeah. So today my talk will be cover 3 different parts. One is why semantic search is not all you need, especially when you do direct applications. Second is how we going to do it, why it is better than like a lot of the existing solutions. Last one, I want to give a quick demo about how you can just write very simple code to implement like RAG with hybrid search. Okay. So. So quick recap about like RAG. I'm pretty sure like everybody here should think like our heard about RAG, right? So it's actually simple. As simple as you can do is just put everything chunking, put into RapidDB. So put everything into a RapidDB, and then like when you want to do queries, you actually embed your queries, search into RapidDB, and then you get some of the like feedbacks, and you store it on your like large language models. Then you can get a reliable answer, right? Remove some of the hallucinations, right? Sounds to be really simple, and it actually works pretty good. Until one day, when I was trying to build a RAG application by myself, I worked with my friends. What we're going to do is actually a legal like applications. We actually have some kind of very special legal terms in the document, right? So when I using this RAG application as well, I just using as like RapidDBs. At first, it looks to be really good, but if you take into a deep consideration, you'll see that some of the terms actually not searching as effective. We actually saw the search become like overly broad. So if you search for one term, you may get some similar terms, but there's nothing that control this, right? So I'm trying to start thinking about how we can fix that issue. I actually using two solutions. One is just fine-tuning my embedding models and also large models. It works okay at the very beginning, but soon I find with more and more corner case, when I start training my fine-tuning my bad cases, I saw like large models started forgetting a lot of like basic information. The main reason we use large models or embedding models is just like they have been pre-trained with a lot of like existing information, right? So with a lot of fine-tuning, they start to forgetting, and with the score actually, the evaluation score actually goes down, right? So the other way I actually tried is doing query rewriting. So I'm trying to find all the like synonyms for certain kind of terms. I try to change the way of speaking, use larger models to change, like doing a lot of tricks on that. But at some point there are like just too many corner cases, and you cannot fix it for your use case, right? So there seems to be nothing you can do. Okay. If you look at what is actually wrong for semantic search, right? It's definitely not all you need. It's actually pretty good technology. We build record DBs, so I won't say like record DB is not good. But they are like lacking three major things, right? One thing is there's no way you can control your results, right? You just like larger models, they're basically just a black box. So why you get this result, why they become similar is all a black box, and there's nothing you can do if things go wrong, right? Second is that it failed to handle some uncommon queries, right? So this many models is trained by a large data set, but still actually the data set is coming from the web, or those are very common stuff, right? But under your use cases, you may find that for some special term or special like queries, it works not pretty good. Sometimes you don't even see the token like in the training data set. So it won't work, right? Third thing is always about chunking. We all know that chunking is not easy. The easiest way you can do is just a chunking by 4K, 8K, but there are a lot of trade-offs between, right? Long chunks, you lose all the context, or you lose all the details. If you're using short chunks, like 512, then you lose some context, right? So it's always hard to like how you chunk it. So how we think about a way to fix that. So when I started thinking about what makes search very powerful, or what is the like way we can do search, I think it's all about probability, right? So no matter it's large models, no matter it's embedding models, so the only thing you want to do is like trying to find like some patterns in our like documents, in our corpus, right? As easy as it can be, if you like calculate the frequency of English letters, you'll definitely see some letters get higher. For example, E is actually shows much more frequent. So if you want to build a small large model to predict the next word in the document, I will also keep PPE if I don't have enough training data set, because that makes most sense, right? Same here for 2 gram. So if I put 2 letters together, you definitely see some of the patterns is actually not staying there, such as VX, GQ, but some of them are very popular, such as TH, right? So same thing happens here when we put into not only about letters, but if you put into tokens, that's how large model works. So just to predict your next tokens, right? So with enough training data set, then you know what is the highest possibility that could be the next word, and you know which kind of like the letters actually or tokens are actually most similar, right? So the question is how do I improve the probability, right? One way to do that is always using pre-trained models. OpenAI is definitely pretty good. We also know a couple of like embedding models, Voyage AI, Cohere. We train from like massive amount of data. If you try to build a legal data set, they have law models. If you're doing a finance data set, they have like models training for those specific data set. And sometimes can do some fine tuning, but I think those tricks are not like works pretty good on some of the use cases, right? So the other way you can do that is to figure out your own data distribution. And that sounds to be very, very difficult, but that's not that hard, right? So the way we do that is actually very traditional, but it's actually really helpful. To start from, we need to recap. So those part will be a little bit technical, but hopefully that I can give you a like general background about what's happening here. So the very traditional way we can get these stats is something we call TF-IDF. So TF means term frequency. So it shows how much time each token shows in your corpus, right? So the other one is IDF. It shows that the frequency of each token among all your documents. So for example, if I have a lot of words in the same document or in my corpus, which means this token is not going to be very important. It could be a the, it could be a or it could be like very common tokens, and it doesn't contain enough semantics, right? But if you saw some very special words we never saw it before, it only shows once in your corpus, then which means their IDUF is going to be only one, and its width is going to be super high, right? So if you get all your data set, if you do all the stats, calculate all the term frequency, all the in-word document frequency, then there's actually a way to calculate the relevance between your query and also your like corpus. That is what we call as a TF-IDF. So Elasticsearch and all like Lucene-based like search actually using the same technology, but they definitely different versions of how you can calculate the stats. One of the most popular ones is called UM25. So they generally using the same idea, but they change some of the like hyperparameters to make sure that search makes more sense, right? Okay. So what could happen when you're using TF-IDF? So it's generally three different steps. The raw text here is Milvus the vector that is built for scale. First part, you have to split into different tokens, just like large and model do. You have different tokenizers. Sometimes the easiest way is just a split by like 4 letters, 5 letters. But you also can use a lot of different like stop word, using comma to split everything. For sure, we have some integration stuff for that, so you don't really need to worry about how to tokenize. So after you tokenize, you do some transform, make sure that you do lowercase, you do stammer, you remove some of the very common words. So now you get some clean tokens, right? With those tokens, second step is you actually have to do invert index on top of it. So I'll show what is the invert index, but it gives you some like performance when you try to search on those, right? Third part you need to stats. That's how we figure out our data distribution. So the important part is that we need to calculate, for example, how many times Milvus shows in my document, how many times vector shows in my document, right? Ideally, vector should be like showed more compared to Milvus and other, because vector is like more like a common word, right? So which means if Milvus shows it, it's actually going to be more important than vectors because it shows that in all the documents. So I can give a quick example about what happens. So I have 3 documents. One is information retrieval is a field study. Second, the information retrieval focus on finding relevant information, whatever. Third is that data mining and information retrieval overlap in research. Okay, so those are 3 documents I have. If I search for information retrieval research, which one should be more important? Yeah, I think ideally definitely number 3. First of all, because all the 3 tokens I have, information retrieval research actually showing document 3, right? And what about document 1 and 2? Which one is going to be more relevant? Yeah, the answer is document 1 is going to be more relevant because document 2, they both have information retrieval as a keywords, so it's all there. Information actually shows much more times, so it has less weight. Retrieval shows like less than, if only 10% of your document has retrieval, so it's become more important. And after you do all the calculation, and sometimes you also need to divide it by the length of your document to do some kind of normalizations, and you can also like always calculate the scores, right? So that's a normal way how we using BM25 to evaluate how query and document are relevant. Okay. So it sounds to be really good, right? So we know we have a way to control it. We just need to know about the tokens. Everyone can read the tokens. We can modify on that. We can do filter on that. Is that good? The answer is not. It's not enough, right? So that's why we still need vector DB. Reason is, first of all, sometimes you lose your context by just doing semantic search. By just doing lexical search, you're just trying to find most similar words. But sometimes, for example, the apple word, they have multiple different meanings. Do I mean the fruit apple? Do I mean the fruit company? Yeah, so that's going to be one challenge. Vector DB or vector embeddings definitely help to understand the thing, like behind the scene, right? So the second thing is, what about synonyms? So sometimes even if they have similar letters, similar words, they have like different meanings. But on the other side, even have totally different words that might have similar meanings. That's why vector DB or vector embeddings are going to be your very important for this case. Third is about your intentions. Just by looking at the word change crosshair, if I have different contexts, if I'm looking at the e-commerce website, or if you're looking at the car manufacturer website, I actually searching for different things, right? So it's not, so just using like keywords or just using lexical based search won't help a lot of these use cases. So that's what we propose in Milvus 2.5, which is a new hybrid search model, combining both lexical search and semantic search. So first of all, it works pretty good if you look at the numbers here. So by just doing dense or sparse, you can probably get 50%, 60% of your recall at most. But if you combine all of those and do a re-ranking, definitely shows a lot of like improve on your search politics, right? So we actually using a model called BGM3, so you can generate multiple different embeddings. And BM25 is kind of the same. You can combine both BM25 and also operation model together to get a better result. Okay. So what's the challenge here? So if it's already so good, why it's not like put into production, right? So a couple of things is actually the blocker to put hybrid search into production. One is it actually makes your architecture more complex. So this is a very common architecture. Right? For Lexis search, a lot of people use the Unstructured, using open search, using Solus, and here I'm not pretty good at like dense semantic search for performance for cost. So that's why you also need this like a special vector DB, which is your Milvus. I know there are like some others, but generally what you do is build a system. You have a search service. It helps you to do ranking, how to store all the raw data. But you also need a system for lexical search and system for semantic search. You also need your embedding models, right? So that makes your system become very, very complicated and no way to maintain it, right? Second is with multiple different embeddings, also like the cost issues, right? So you see like you have to double your cost, sometimes it's like even triple your cost because you maintain multiple different embeddings, right? And also you have multiple different like bottlenecks, right, on your performance. So it's very hard to diagnose, it's very hard for observability. Okay. So that's why we start to think about like merging into one large cluster or all one like database can host both like vector search and sparse search, right? So this part is going to be a little bit technical. So it gives a little bit background about what is the traditional vector search engine or what is the ES do. So generally speaking, what they do is they're using an inverted index. So for each of the token, they actually like list how many documents actually contains this token, right? For example, if I have like a Harry Potter book, I split into different chunks, and Harry is going to be my token, and for different chunks, token 1 has Harry, token 2 maybe has Harry twice. So that is how I made this inverted index list, right? So when search happens, the easiest way we do is called DAT, short for document at a time. So we just quickly go through all the relevant. For example, when I search for BCA, in my use case, BCA are just different tokens. So I start from B, I say, okay, D1 is actually related. So I go to C, D1 is related as well. So I add up all the score here. And A is also related to D1, right? So D1 gets a score of 2.5. That's a relevancy. So the one is actually the BM score where we talk about, right? So then we go to the next document for D2, the D3 goes one by one, and you see that if your emerging piece is gonna be long, it takes you a lot of time to like go through all of this, right? That's why the performance is not really good. So there's definitely some smart way to improve on that. So I won't talk about those details, but remember there's actually called weekend or WN. So the overall goal for this algorithm just to skip some of the tokens or skip some of the documents. For example, if I already find one very relevant document, the easiest we can do is we can skip all of the documents which don't have enough width. So you don't really understand that, but under that case, you'll see that D2 is actually the score is actually much smaller than D1. So we skip it and directly go to D5. So if you guys are interested, there's actually a very good paper about this. This is a very like basic paper for all the like search. So I would recommend you to read more about this in the paper. But is there any like drawbacks for WN? Definitely there is. Otherwise, we won't build it in Milvus. I think it's hitting to a lot of performance issue on many of the use cases. It has large update, it has large chunk size, it has a lot of long queries, but that could be the case in building RAG applications. If you think about traditional search, usually people just keep searching like 3-4 different keywords. But on the RAG use cases, usually a query gonna be long because everyone's talking about you need to give more context for your large models, right? So people tend to write longer font, right? So search becomes more like performance intensive. So that's why in your 2.5, what we use is something called a hybrid index, right? So it's a little bit different from traditional index. The two major differences, first of all, we have multiple different index implementations. Just using word index, we also have a graph index. If you guys are familiar with VectorDB, that is going to be used for density mining as well. Graph-based index is actually pretty good when you have long context, when you have large top case. And the better part for the graph index is you can utilize a lot of like machine learning things. For example, you can do quantization on top of it. You can do a lot of like hardware acceleration on top of it. We use CMD. All those are actually written in C++. So the performance is actually much better. Sorry, the graph is a little bit like small. But just to give you a very quick idea, so we did some tests on many of the data set, and the results say that almost on the similar recall compared to ES. Memory usage for Milvus like it's quite less compared to ES, and the performance is usually 2 or 3 times faster. That's simple because we utilize the different quantization policy. So the recall gonna be lower a little bit, but you see like high performance growth and also like more memory saving. So the background seems to be really sometimes it's gonna be hard to understand if you don't have the background, but don't worry about this, right? As a user, usage is gonna be very simple. So it's just gonna be take 3 steps. First step is create your caption and or your schema information. So from the code here, you need to actually specify a function, help you to do all the embeddings. Here we have BM25 functions, right? So you actually specify the input field is actually text and output field is sparse. Okay, and using the like BM25 to do all the embeddings, right? So that's the first step. You have a collection. Second step is you have to build an index on top of it. So the index we're actually trying to build is the word index. We also have the graph index version, right? Bunch of parameters you really don't worry about it. And third step is you need to insert your data. So your data just be onto pure text without any embeddings. That's a major difference between Milvus 2.5 and all the previous versions. So for previous version, it's almost vector in vector out. So you have to like do all the embedding generation by yourself. But right now with all the functions, it can help you to do all the embedding generation. So you only need to offer the like full text, right? So we're also working on the density embedding part. So we try to integrate a lot of like different embedding models and regression models. So using vector database is going to be much easier. So you don't really need to worry about how you handle that, right? So after data is actually going to be inserted, you just search with another screen, like who's already answered. Yeah, so as that easy, you actually do the very basic demo for like sparse semantics, and you can also work sparse semantics together with this semantics for like better performance. So we're just going to release this Milvus 2.5 version. So just next week. So this is the first time I'm talking about all the new features here. So feel free to talk to us. This version will be very focused on like having more search functionality. So not only for BM25, but we also have keyword matching. So for a very long context, if you want to figure out one of the document with keyword Milvus, that is actually doable. We have multiple different indexes to improve the filtering performance. We also add a lot of different consideration help users to reduce their cost when they try to do web search, right? So right now we'll be like preparing for Milvus 3.0, so we would also like to hear about your feedbacks. So in the new version, which is starting on like early next year, we also have interesting features like UDF, like hot code data separation. And now a lot of people trying to do multi-tenancy. We actually have a talk about multi-tenancy. So one of the key challenges here is how to speed the cost for a lot of code tenants. So that's one of our goals for 3.0. Yeah, but feel free to grab me, give me more feedbacks about what is the feature you actually need. So we keep improving you like for a lot of like AI applications, right? So yeah, so one quick thing about who we are. So in case you don't know Milvus, so we kind of like the most widely adopted vector DB on GitHub, open source for sure, under Linux Foundation umbrella. So we have more than 400 contributors, over 30K stars. Yeah, we move very fast, and over like 1,000 enterprise like companies actually using Milvus as their vector DB. Yeah. So if you have any questions about us, feel free to comment. All right. Thanks.
Do you just want to stay there for a second?
Sure.
Yeah, thanks so much, James. I think this idea of like using semantic and lexical search in like a complementary way, I think is really powerful. So I think we've got time for maybe one or two audience questions. Okay, Gagan, how would you like?
Can you double click on the solar versus Milvus performance?
Oh, the performance.
Oh,
Why Milvus versus solar?
And can you repeat the question for just for the recording?
Sure. This week? Or
Yeah, or generally why?
yeah. So the question is why Milvus is actually faster compared to Solar or the other Lucene-based lexical search, right? Yeah. So as I just said, one is a pretty good algorithm, but it has some major drawbacks, right? When you have long query, then you have to like iterate through each of your like inward indexes, right? That takes some time. Even if you can like skip some of the parts, but skip is not always working. It's just taking some of the weights. And if you have longer top K, then things even become worse. Or if you have larger top K, right? So that's why the first thing we do is we use graph index on some of the long queries. So graph index is actually much better if your query get longer. So because instead of like doing one by one, they just skip based on the nearest neighbors, between like edges between different nodes. That is one thing we do. Second thing we do is we apply a lot of composition into the traditional index, right? So if you're familiar with the vector index, we have scalar composition. So basically we turn FP32 into int 8 or into FP16. So it helps you to save your memory and calculation actually becomes faster. So we take the same technology into lexical search as well. So it saves your memory and also accelerate the performance. The major drawbacks is you have to reduce a little bit of your recall, right? So the third thing we actually do is we use a lot of safety instructions inside the vector search, right? So for Lucene, they just included in Java, so it's not working very well on all the safety instructions. So we use C++, so actually we can like play with all the instructions to accelerate.
Okay. Yeah, thanks. So yeah, let's thank James again for the really interesting talk. Um, I'm feeling super excited about the Milvus 2.5 release, and it's not just because I work there. I'm, sincerely excited about it. So let's welcome our next speaker to the stage, Dinesh from Unstract, and he's going to be telling us about some challenges of getting structured output from your unstructured data at scale. Take it away.
Thank you. I need a mic.
Yep. Let me just grab that. Okay. Perfect. If you go to view, view, yeah, go to view, and then you can make it full screen. Oh, well, okay, excellent.
Okay. Good evening, everybody. Hope everybody has some pizza and all that. My presentation is going to be like, 10,000 feet above from their keywords. It's going to be like, keyboard really after like watching the art project. So, this is going to be fun, because we're going to be talking about a particular aspect of GenAI and everything that's happening pretty much across the board, where we all acknowledge that 80 to 90% of data is unstructured data across our enterprises, right? So one of the things that enterprises are struggling with these days is extracting structured information from that, PDFs mostly, images as well, and getting those out in a very meaningful way, right? But the most important thing is there are two elements that will drive what kind of tooling you use. One is accuracy, the other one is cost. So between these two, we determine like how or what approaches we take, what kind of tools we use. The way of introduction, my name is Dinesh Chandrasekhar. I run a company called Stola, through which I enable a lot of startups. I'm a fractional CMO at Unstract, which is whom I'm representing today and talking about it. If you wish to connect with me on LinkedIn, please feel free to do so. That pure coach will take you. And I have a wide range of experience in the data, AI, and automation space, so I'm happy to chat with you offline as well. So first off, let's address the elephant in the room, right? So when I say document trouble, what does it actually mean? Right? PDFs come in all kind of formats. Scanned PDFs, traditional PDFs that have been generated, PDFs that are from a particular system, transported PDFs that have been attached together, all kinds of stuff, right? And manual extractions take a way lot of time, particularly when you talk about RTA and then the intelligent document processing kind of modes and all that extraction. It takes a lot of time. And they may not be immediately available. Like unstructured data is not going to be immediately available for real-time analytics that you need in your enterprise. Most of the data is sitting inside the PDF, so it takes quite a little bit of time to extract that and put it into your system for you to actually use it for analytics. And most importantly, errors. So which is why I talk about accuracy, right? So errors are introduced by even having humans in the loop, right? So when they look at a PDF and copy paste or look at it and type it into a different screen, you're introducing errors. So you want some kind of automation that makes sure that you can not only extract data, but also automates the delivery very quickly. I mean, the challenges are obviously you understand this, right? So there's first-party product experience. There are cost implications, there are accuracy implications, which lead to brand questionability and all that. So, what does Unstract do? Which is what we're talking about here. Right? So I'm going to use this as a mechanism to show you a demo and all that stuff. So I have only a few slides to bear with you. With Unstract, what you can do is you can ingest any number of large PDF documents. Right? So there is no limitation in terms of what kind of PDFs you can ingest and what size and all that. And you can convert obviously what kind of unstructured data into structured data. And it's not just taking the raw text as is, but you can also query it, interact with the document, and extract what you need from it. And the way of doing that is it leverages LLMs. So you can pick and choose which LLM you want for your needs, and you can use that to extract the data. By way of which, again, you are addressing all of the challenges that I spoke about earlier, right? So cost implications and the automation piece of it, as well as the instant business insights that you need for these kinds of automations. in terms of brief history of document extraction for people that haven't been following the space, early techniques were like, predominantly OCR, right? So that's predominantly what we used to have. And I mean, OCR still exists in a lot of places, but OCR is considered to be legacy in terms of technique for extracting this type of information. It practically scans it and extracts it. The second generation would be like more ML based, where you can indicate XYZ coordinates and say, here's where the particular data is, here's what you scan, and here's what you get, and all that. You can indicate and teach it. But once the format changes, it crumbles, right? So that's the other challenge. The third generation is where we are right now with LLMs, right? So now LLMs actually can understand a PDF like the way humans do, like they can read the text and parse it and make it more meaningful for you to implement. When you say in a credit card statement, get me all the line items or transactions that I've had in the last month, it will be able to interface and get that out for you, right? So that's kind of like the level of interaction that I'm talking about. Unstract is tech agnostic, so you can basically use any LLM provider you want, any type of vector database you want, Milvus including, any type of embeddings and etc. Right? So you have all of that. Unstract has its own text extractor called LLM Whisperer. You can check it out. It's its own capability. It's actually pretty solid, and that's what drives this whole technology here. But the predominant part of the prompt engineering tool that I'll be showing is open source. So you can also go to the GitHub libraries and download it and play around. So, two phases of processing that I'm going to be showing. One is the prompt engineering phase, which is where I will show you a PDF and I will, write prompts and actually, get data out of that structured PDF, unstructured PDF. And then a deployment phase where that same thing can be deployed as an API. And now I can use this API practically in anything, right? So if I'm building an automation tool, having my own Gen AI application, anything at all, I can use the API. So demo time, right? So I said very minimal slides. I actually had a thing to say about RAG, but because we had a fantastic RAG session, I'm not even going to go into explaining what RAG actually means. I think you got the gist of what actually RAG does, right? But in this case, I'm going to be using Milvus as a part of this, demo. So I can put Milvus in there and kind of try to show you this. The only thing that I'm going to talk about is the structure that I'm going to demonstrate. One is I'm going to show you how to actually get data out of this PDF without using a vector database, right? And it'll matter. It'll matter because when you use smaller PDFs, let's say 1 page, 2 page kind of a PDF, it'll be very easy, very quick. LLMs understand as long as the document is not super complex, and it should be able to fairly understand what data is there, how to extract it, and all that. But when you have let's say a 100-page PDF, 200-page PDF, and all that, that's when you really need something. You need a vector database. So you need to be able to take chunks out of it and put that into vector and have the vector actually do stuff. So I'm going to show you both, right? And you're going to see the benefits of using vector versus not and all that, right? So in terms of again cost and accuracy. So that's what we're doing. The one thing that I'll point out is when I'm using the vector, I'm going to be using two retrieval mechanisms. So one is a simple retrieval mechanism, the other is a sub-question retrieval mechanism. I'll get into it and then I'll show you what I actually do. Let me switch into. Very good. Well, I get this full screen mode. It's not coming on. All right. So this is the Unstract prompt engineering tool that I was telling you, right? So it's called the Prompt Studio. And what I have here is a bunch of projects that I built, right? And what I mean by a project is, I'll show you in a second. I built.
Oh, Dinesh, could you increase the font size at all?
Yeah, when I get into a particular thing, because once I zoom in, that will be harder. So let me get into a particular project and then I'll do it. So I'm going to pick this project which says, thank you parser. Thank you is a document which is a complex, company document that gets submitted to the SEC every quarter and so forth. I'm going to be parsing that without a vector database, right? So I'm going to pick this, and what you'll see here That's as good as I can get, sorry. What you see here is different prompts that I've written. So I'm just saying, what is the name of the registrant specified in this particular context? You know, what is the commission file number and things like that. These are actual prompts that I'm writing, no code, nothing, right? So I'm actually like prompting into this, and it is querying the PDF, the LLM behind is querying the PDF, and it's getting the data back from me. Now you might ask which LLM I'm actually using here. I'm actually using two of them, right? So there's one GPT-4 or the other one's Claude 3.5 Sonnet. And both of them are like, you know, kind of getting me comparative results of like one saying Apple, the other one saying Apple, obviously, and I'm using an Apple NQ document here, so that's what it's doing. It's also showing me the number of tokens this one is used and the cost it's used, right? So there is a same thing here. That's what is happening. And you can see the cost difference between like using Claude versus this and all that. And you can evaluate this as you go through it. You're gonna kind of evaluate all through this the complexity as well. Like for example, here I'm using a JSON output instead of like just plain text. I'm saying I'm getting a JSON output, and I want like the full address, city, state, zip code, and all that. And it will also be able to like format it as a JSON. Again, plain text. That's what I'm like doing here. Now, when I do this, and what I can do is I can actually deploy this as an API, and I do already have it deployed as an API. And you can go in here and practically download Postman collection from that. And I have Postman set up here. And let me just process the same 10Q parser without vector DB thing here, right? So and if I use an Apple 10Q document here, you can actually use any 10Q document as a matter of fact. It doesn't have to be an Apple 10Q. But in this case, I have a different version. It's a Q2 version while I tested it or built it originally on a Q1 version. It has actually given me the results, right? So the API came back with the results here. All the text that you saw earlier in the output is like all here, right? So what I'm going to do is I'm going to like scroll to the bottom here to show you one quick thing before we jump into this. This is the section. Let me zoom in here a little bit so you can see. So if you see here, you can see the cost in dollars for the overall document for all the prompts that I gave, right? It's showing me it's $1.4. That's the total cost. The input tokens and output token, everything is listed out here, and it's used GPT-4, and that's the output here, right? It took me $1.40 to process the document for all the prompts that I gave it. This is without using a vector database, right? So that's what I want you to remember. Now, going back to Unstract, in the same prompt studio, if I now pull up one with vector DB, right? So this is a simple retrieval. So in this case, what I've done here is if I go into like settings here, you will see that I'm actually using a vector database in this particular case. In this case, it's Milvus, right? On this cloud, that's what I'm using here. And I've set it up. And if I go into the edit mode, you can also see the chunk size that I set up, the overlap that I set up, everything is set up here. And the retrieval strategy is also indicated here, simple versus sub-question and all that. So I told you I'll talk about it, right? Simple is practically saying, send it as is, right? So without like changing anything or like submit the query as is and get whatever the vector DB gives you, right? So if I say ask for address, it's going to ask the vector database for all the chunks where address is, and it's going to return me all the chunks, and I'm going to get all of that, right? The sub-question part of the retrieval or that strategy would be where it recursively iterates and gets me only those chunks that are relevant and eliminates the duplicates, and it's more accurate than this. And I'll show you how, right? So in this particular case, same thing, right? So same kind of query, the different 10Q here. And I'm asking for like the same kind of questions. What is the registrant's name, commission file number, and all that? It's giving me the same results now, regardless of what I'm using. It's a fairly accurate. And if I go to Postman here, and if I look at the other one here, I've already executed it. So for the sake of like time, I'm just going to like talk about it. It's showing me the same thing with the vector database, the same document, the same Apple 10Q document that I showed you, executes at like 17 cents, right? So what was originally like $1.40 without like using vector DB now is showing me at like 17 cents, right? So that's the kind of cost effectiveness that you're seeing here, right? And accuracy again will also like improve the more and more complex queries you start using, you'll see more accurate results return back as well. And while I'm here, again, in the interest of time, let me also pull up this sub-question retrieval thing that I was telling you about. And in this particular case, the results are going to be with, again, 23 cents, right? In terms of cost, it's leveraging the vector DBs, but it's again doing that recursive querying of asking this. The recursive querying actually helps when you have like a really complex prompt. And I'll show you an example of what a complex prompt looks like. Because in this case, I'm actually asking like one prompt at a time, which means you're hitting the LLM every single time there's a prompt here, which is not the most ideal, pragmatic, practical way to actually do it, right? So what I would want to do is consolidate all my prompts together and then send it to the LLM, and which again with leveraging the vector DB actually makes more sense. So in this case, let me show you what one such thing looks like. So let's say I created a compact 10Q parser question with sub-question retrieval. This would be, let me just make it a little bigger. So in this case, what I've done is I've practically consolidated a lot of those prompts into like one single prompt, right? So I've just said, create a JSON object, get all the disclosures, get all the details, get all the risk factors, everything, put it into this particular format, right? So this is not easy enough because when you say risk factors, it has to like look through this 90-page document and it has to understand where all these factors are, put it all together in a meaningful format and all that, right? And so when you look at how GPT-4 and Claude came back with the results, you'll see that now each has a different way of like returning the result. One says, foreign currency risk and talking about it in a certain language versus like Claude using it in a different way and so forth, right? So both are going to be like very different in terms of that. And in this particular case, we're actually seeing values when it comes to, because I use the sub-question retrieval, it is actually going in for like, complex questions like get me all the income details across like different quarters in the particular 10Q, right? So it goes in, looks for the current quarter, what the net income was, what the quarter name was and all that. And it does that the same quarter comparison from last year and all that, right? So these might be in different pages, different tables that span across different pages. These are like really complex formats that are not easy to format or query with like OCRs or like traditional techniques that we've been using. And this is why like LLMs are like super powerful when it comes to like handling. The same compact parser, if I use let's say the simple retrieval technique, you will see the difference is that the format is the same, right? So I'm using kind of like almost the same long format and like giving it all that. But at the end, I'm also like saying things like more instructions, hey, return a JSON object, not a JSON array. Any income report should be returned as a number with formatting, blah blah blah. So I'm giving it a lot more instructions. This is not easy for vector DB to like process unless until you kind of like break it down into like individual prompts. So you need to use the LLM to like make this complex prompt into like simpler prompts and then send it to a vector DB. But if you use a simple retrieval strategy, it doesn't do that. And the result you will see here is it actually returns nulls for a lot of things, right? So net income it returns null and all that because it's not able to understand how it is able to like get that data, how it's supposed to format it and all that. So it fails that, right? So the point is that the right combination of using this kind of a tooling like Unstract with vector DBs actually produces like phenomenal results when it comes to accuracy and cost, which are like the two important factors that you want to consider when you're treating this. So quick show of hands, like while I jump into the last part, how many of you are like involved in projects that deal with like unstructured data or extracting data from unstructured? Like quite a few hands. Good. So would love to like talk to you after the session as well, about like any other things that you're facing in terms of challenges and stuff, and how this felt or resonated with you, and if I can help you in anything else. Take a look at the tool. As I said, it's like open source, download it, play around with it. There's free trials and all that on the website as well. There are mechanisms that you can leverage this for, right? So You can set up your own LLMs, whichever LLM you want. We support like pretty much all major ones. Any kind of vector DBs you want, embeddings and text vectors, you can use all of those. Customize it and play around with it. And let me know while I jump back to my demo in the last thing and show you this. So this is the two things that I spoke about, the simple versus the question. So again, if you have more questions, you got an SME that you can talk to as well. But I'll be happy to chat about this. And summing up what I showed you, right, in terms of a full document that I submitted as is without vector DB, cost us like $1.40. Accuracy is good, but at the same time, it's not going to be cost effective, particularly when you're dealing with like hundreds of thousands of documents that you need to process on your daily basis. Take inference in this case, financial things in this case. It could be like expensive, but it'll then the simple retrieval model, but not as expensive as I'm saying full documents. So context windows, number of tokens, everything matters when it comes to processing this. A lot of us don't think about it that deep unless until you start processing it at scale. So that was the whole point of the topic here, that it is about extracting data, structured data from unstructured files at scale and leveraging tools. Yeah. Hopefully that is helpful. I got like links and stuff, and you're welcome to click the my screen once they send the slide, you can click them and download it and do stuff. That's that QR code to the trial page if you want to look at that. Okay.
Yeah, we're good on time. So yeah, thanks so much, Dinesh. I think this sort of like getting structured data from your unstructured data, that's definitely one of the killer apps of generative AI. A big topic at this sort of meetup. So let's open it up to questions. I think we've got time for one question. Does anyone have a?
So the cost doesn't include the vector database. So when you calculate the cost of the vector database.
And could you just repeat the question for the recording?
Yeah. So he said the cost doesn't include the cost of the vector database. What was the cost of that, right? So you need to talk to those guys. So there's always that part, right? So it involves an ecosystem to build solutions like this. Right? You can choose to do it without vector DB, but at the same time, as I said, if it's $1.40 per document and we are processing hundreds of thousands per day, you do the math. You're actually going to get ROI for the vector DB in a day. So it's like this or that, right? There is not a good ROI or a TCO model that's been published out there. I'm actually thinking about writing one, and if anybody in the crowd is actually interested in joining, ping me. I'll be happy to write it, because these are the kinds of questions that you generally face. Because people don't understand what's the total cost that I'm going to be incurring when I kickstart a project, AI project. But the cost of not adopting as well could also be super expensive. Cool. Thank you.
Thanks again, Dinesh. So let me introduce our final speaker for the night. So we have Rob, is it Quiros or Quiros? Quiros, okay. Who's from Kaba, and he's going to be talking about an aspect of generative AI data. Would you say security?
Yes.
Yeah.
It's a dirty word for most developers, but yes.
So yeah, something like you may not have thought about, but I think is something that is really super, super important, especially as all these technologies get deeper and deeper into industry. So take it away, Rob.
Well, thank you, Stefan. We take a minute to get set up here.
Oh, sorry. Let me, so it's muted. Can I press the button underneath? There we go. Right.
Okay. Am I still connected?
I think you may need to open the meeting. Just bear with us while we sort out some technical difficulties.
Does anybody need a bathroom break? If you just need a couple of minutes, it's probably going to take me just about as long to get this up as it will for you to run to the restroom if you need to.
So this is where we need a generative AI agent to help us, sort out these sort of difficulties. So maybe someone could build that.
All right. Where is my Zoom app?
Isn't that the Zoom app there?
Yeah, but why doesn't it show me share?
Well, you're not actually, are you in the meeting?
I should be. Aren't
I
I?
think join,
Okay.
and then can you go back to the link? So the link in your email.
My email.
Okay, so yeah, now you looks like you're in the meeting. So join with audio.
Recording in progress.
Now just share your screen. And yeah, this one. Sorry. So anyone at the back, now's your time to sneak a seat while the other attendees are using the restroom.
All right.
Okay, it looks like we're good. Yeah.
Great. All right, we'll give it a couple of minutes for people to come back. You think so? Okay. All right, folks, I'm going to get started now. So Caper's been quite a journey for me. So I wanted to share with you some of the capabilities that we've been able to develop. First, just a brief background on myself. I've been in the IT space, places like Cisco, Akamai, Riverbed over the last 30 years or so in the Valley. So spent some time, a lot of time in networking and security. One of the things, the last company I was with was a company in the SASE space. And I started looking at how applications are evolving and how we can secure them. And this is a result of some of those, answering some of those questions. So first thing I want to just mention, just a level set here. When we're talking about permissions and access controls on data, one of the fundamental things that we're trying to do is to keep Alice's data from Bob or your data from your competitors. And oftentimes the goals of protecting the confidentiality, availability, and integrity of data get lost in words like sensitive data and privacy and PII and PHI. All of those things are very important, but at the fundamental aspect of permissions and access control is if it's your data, you want to be able to control who has access to it. So proceeding with that idea in mind, that it's really permissions that are the most important thing in terms of building applications that are using either customer data or your data or employee data is permissions. We need to do this from a trust perspective, from a compliance perspective, obviously from a security perspective, if there's attackers that are trying to get at this data as well, and privacy. And if there's any better underscore to the fact that this is important, you can look at Glean's $4 billion valuation now, and the number one thing that they talk about is how important permissions are in terms of enterprise use of generative AI applications. So if you want to think about what I'm doing, what Caber's doing in very high level, we're giving every generative AI application the ability to put permissions on the data that's being used. One of the fundamentals of security is it needs to be deterministic. Authorization needs to be deterministic. We can't guess if it's your data. We can't use probabilistic techniques to figure out whether or not we should give access to somebody, because then we're going to be in with some non-zero probability actually giving people access to data that they shouldn't have. And so one of the I guess eye openers you could say is putting a permissions boundary that's deterministic around Gen AI, given that it is completely probabilistic in nature, is very important. So, and I know James talked about this in the beginning, the partitioning and multi-tenancy, and I think that there's a lot of great features and functionality that you can get in systems like Milvus and other vector databases and other databases, which are great for separation of customers, multi-tenancy in particular. One of the places where I've seen it fall down is when you start looking at it from a user access control perspective. This is where we ran into some troubles back at the last company I was with. I was building a SASE solution, providing user access to internal enterprise applications. Just because of the number of different variations on what these permissions need to look like. You're all familiar with terms like RBAC and ABAC, attribute-based access control. And now there's relationship-based access control, REBAC and such. The number of different ways that enterprises want to be able to provide access control is complex. It introduces a lot of complexity just in terms of not just whether you're trying to provide a user access to an application or user access to the data, but also from a support perspective or from an administrator perspective. You have to take multiple different constituents into account when you do this. So how can we do all of that in a vector database? It becomes very difficult. So, well, difficult, but a small matter of programming, right? If you wanted to put it that way. But dynamic privileges versus static permissions doesn't seem to work too well. This is just a screenshot from this company, Permit.io, that's doing REBAC access controls, where there's a complex path that they need to go through in terms of providing a doctor who may be visiting with you in the exam room, needing to pull up some data in the moment and then be able to provide a prescription or something like that. And it's only during the session that he's with you in the exam room that he has access to this data, which is a pretty complex way of trying to formulate an access control to a specific chunk of data. So that's one of the key issues, one of the problems that companies face when they're trying to build access controls on top of Gen AI applications. The other one is that it's actually not the user that's accessing the data in the vector database, right? It's the agents that are acting on behalf of the users, doing the queries into the vector database to retrieve information that's coming out. So this ends up being just a small matter of security because, well, you can't authorize the agent access to a user's data without giving that agent very broad permissions to access all of the data that may be in a system. Now, one way you can think about it is you could have the agents spoof the identity of the user. Let's just borrow their credentials, we'll borrow their group IDs and access roles and such. But this ends up being a big loophole in terms of security, because now you've given the agents the ability to do pretty much anything that the user is able to do. And if that agent ever gets attacked or compromised, then there's almost no limit to what an attacker could do in this situation. Now, certainly you can build in all sorts of protections, but then this becomes a very, very complex path to go down. So the third problem, and this is probably the one that's not talked about very much, is duplication of data. There's a lot of research that's out there in terms of the detriment of having duplicate data in LLM apps. I spent 8 years at a company called Riverbed doing WAN optimization and data deduplication. And there's a lot of duplicate data in the enterprise. If you think about Office 365 or Confluent, SharePoint, I'll share a document with somebody, they'll change it, share it with somebody else, multiple versions floating around. When you look at that data from a chunk level, which is what we end up doing in vector databases with the help of, was Unstruct, Dinesh, was the company? Unstract, yes. You run into a lot of duplicate chunks across these different documents. So one of the key issues, though, with duplication of data when you're building a vector database is just the amount of it. If you think about a chunk of data that somebody has access to in one document and doesn't have access to in another document, how do you deal with that, right? And across the enterprise use cases that I saw back at Riverbed, we would see routinely 90 to 95% of the data we could remove because it was data we'd already seen before. So this is really a key issue, right? If you try to just copy permissions directly from a document and put them as metadata into your vector database, the next time you see that same chunk of data in another document, you'll overwrite the metadata and you'll have a different set of permissions. So being able to resolve those permissions on a per chunk basis ends up being critically important here. And I promise I didn't steal from Dinesh's presentation, but I am using Apple 10Q statements here. But it's a great example, actually. If you look at them, just the amount of common boilerplate you'll see across different 10Qs. The differences are very nuanced. They're difficult to predict. If you were to ask an AI to say which one of these is 2023 and which one is 2024, there really isn't the information there to be able to infer that. Unless you're able to look down at the headers and footers of the PDF, and there's a rule that you could use to extract that as metadata associated with it, the classification is going to help you. Pattern matching and regex isn't going to help you distinguish these two either. So how do we do it? Well, we want to be able to identify data at a very fine-grained level. And by identify, I mean understand exactly where did it come from. Because if we can build the graph of the different sources that these chunks of data appear in, we can then algorithmically or analyze what the permissions are and determine by either prevalence or precedence or some policy what the permissions on that chunk should be, not just whether it's what it is in that document at the moment. So that's summing up about a 4-year journey building a solution that does just that. What Caber is able to do is to look at all of the documents that are ingested into a vector database. We build an index on the side to graph the relationships of chunks to the different sources that they come from, the APIs that move them, the users that are accessing them and such, to be able to understand at a very detailed level what the lineage of each of these chunks is. And then like I said, by understanding that lineage, we were able to assign the permissions deterministically to each of those chunks. So just looking at about, 6 or 7 different 10Q statements, this is a graph of what we see after chunking these different documents. There's a lot of common data chunks, which are the red dots at the top. The purple dots in the middle aren't really all that important. And you can see the different 10Q statements that these chunks come from. And there's a lot of commonality. So we're able to look at that and determine, based upon a policy, where each of these chunks should derive its authorization information, its permissions from. And then we can use that to be able to look at the data that's being retrieved out of a vector database and determine whether or not the user that data is destined for is authorized to access that data at the chunk level. So I'm going to switch here to a demo, which should be pretty quick. So the top is user Amy, and Amy's the Apple CFO, and she has access to released and unreleased financial statements for Apple. The 2023s we consider released, and the 2024s are unreleased. So she asked the question, how's Apple's gross margin percentage evolved from Q1 2023 to Q3 2024? And so I built this on top of the RAG demo that Mozilla's folks have so kindly provided. Thank you very much. Appreciate that. We're agnostic to the vector databases. We're agnostic to the LLMs as well. And we're just dealing with some slow Wi-Fi here. Running. Fingers crossed. Wow. Okay. So what we see is, I'll just scroll this down. So she gets a pretty complete answer. Apple's gross margin percentage is a notable increase between Q1 23, 2024. It's pulling in data from Q3 2024. And we can see here on the side is the actual data that was retrieved out of the RAG. And pretty complete set of data to answer the question. If we switch over to Bob, who doesn't have access to the 2024 data, we'll ask basically the same question. Tell me, how has Apple's gross margin percentage evolved from fiscal Q1 2023 to Q3 2024? And we'll see if this goes a little bit faster. So Bob, again, doesn't have access to the 2024 data, but all of it is stored without any permissions inside of the vector database. we've integrated into this application through an SDK. And so we're filtering the data that's coming out of the RAG before it goes to the LLM. So it ends up being a relatively nice experience as far as what the user sees, because we've redacted basically all the data from the 2024 statements. But he still gets a good answer. You know, the context provided does not include specific gross margin percentage from 2023 to 2024. However, and it goes on to give a relatively complete answer. And that is despite the fact that we've redacted quite a lot of data coming out of the RAG. And we're doing this at a level that's smaller than the chunk size that you would use to build the RAG with. So this RAG is built with 1,000 byte chunks, and we're redacting at about an average of 128 bytes. So we're going to see more duplication of data at that level than you would at the 1,000 byte level. But nevertheless, it's very effective at being able to recognize where did this data come from, attribute it to those 2024 statements, and then redact it so that this user isn't accessing any of the data that they shouldn't be. So like I said before, we're integrating with an SDK. We have a number of different identity connectors to be able to get the user authentication information, their groups, et cetera. We also have a number of connectors to be able to basically in parallel build our own index of these chunks, put the permissions on them as the vector database is being built or updated. One of the interesting things that we need to do, if you think back to what I was mentioning, that it's not the user, it's the agents that are making these requests, is we need to be able to track what I'll call the on behalf of connections. So the connections that the clients or the agents are making on behalf of those users. And to do that, we're basically tracking the data that we're seeing in the API requests and responses across these different connections that are being made. And in this case, it's a relatively simple bounce diagram, if you will. But the green is the data that exists in the prompt that the user entered. The agent then uses that to look up data in the vector database. The response comes back, and we're able to track the data across these different connections, across these different requests and responses, to be able to attribute them all to the user Bob. And in that way, we can say, oh, these connections, like this connection between the agent and the RAG, we know it's made on behalf of Bob, so we can redact the data at that point, rather than having to wait until it's actually traversing the path back to Bob. And of course, that's the way that we can give such a seamless experience in terms of the what the user sees. But actually, you know, the ability to do this kind of byte sequence level tracing of data across applications opens up actually quite a lot of interesting capabilities that we can bring to bear. Access control is just the start, because if you're thinking about security in an enterprise, you're mostly concerned about what happens. Well, if you're not a development engineer, if you're a security engineer or one of the on the security team, you're mostly thinking about what happens when something goes wrong. What happens when I'm attacked? And when things go wrong, this ability to be able to trace the movement of these byte sequences through the different services, different objects that these chunks appear in, allows us to provide significant accountability and auditability. Basically, a full trail of how did that data move in any given incident. So for example, if somebody does get access to data that they shouldn't, or if, say, you're using you know, a agentic AI where you have autonomous actions that are being performed by an LLM on behalf of users, and those actions are unpredictable, things can go wrong in ways that, of course, you are not able to predict. And so when they do, you want to be able to find out exactly how did that happen. This is an example of a different demo that we've put together, which is basically tracing data flow from a user that's uploaded that data to the point where an agent has grabbed the data, modified it, and returned it in a response to user Bob. And then every API call that was involved in that transaction is recorded, and we can provide that as an audit trail. And then, of course, when you get deeper into these applications that become more and more complex, being able to understand and have observability in terms of the actual data flow that's happening within those applications becomes very important. And for this, we can provide some very high-level observability characteristics around, whose data moved where, when, and what services touched it. But it also gives us the ability to start modeling if you think of black box modeling, it gives us the ability to model what the application is actually doing. And then this is where our own use of AI gets pretty interesting. We're able to then take that knowledge of how data moves within the application and feed it back to an LLM to find where there may be some security issues, some vulnerabilities, some places where there may be policies that are in effect that need to be modified to meet certain objectives. And so this is actually where, if we look at the complete set of capabilities from access control to auditability to remediation and analysis, we need to have all of those things put together. And that's what we're doing with Caber. So it's pretty new. It's pretty early days for us. And we're looking for folks who have a need to try it out. And we'd love to work with you if this is of interest. So thank you.
Thanks so much, Rob. Really interesting talk. And yeah, definitely can understand that solving this problem of data access control, I guess, have to do it to sort of satisfy a lot of the legal requirements, right? Around
Absolutely.
how data is used in Europe and California. So I think we've got time for one question.
Sure.
In the checks, whenever you have this permission, do you unionize it? Do you add those permissions, or do you take an intersection of the permissions?
That's a good question. So the question was, if we have chunks of data that exist in multiple documents with different permissions, how do we resolve what those permissions should be? And it's by prevalence, precedence, or policy. So prevalence, we see it in one document that's maybe restricted, and in 1,000 documents that it's unrestricted and open to the world. We'll decide that it's probably something that is accessible by everybody since it occurs in so many documents. Precedence, who wrote it first? Who owns the data from the beginning? And if we've seen somebody that is a restricted owner who owns it or who created this data, then we can use their permissions and use their permissions to override. And lastly, policy. Maybe that, like in the case of these 10Q statements, that as soon as they become released, the permissions change. And so you'd want to have a time-based policy that says, if the release date is future, then it's restricted. If it's in the past, then it can be unrestricted. But those are the three ways that we would do it. I'm happy to take other questions offline. And so I'll be over here if you would like to talk some more. Thank you very much.
Thanks again, Rob. And let's give another round of applause for our three speakers, Rob, Dinesh, and James. Okay, so as I like to say, we've finished the speaker portion of tonight. Now we're going to do the giving out free stuff tonight. So you may have exited the raffle earlier on, QR code.
And,
That's okay.
oh, and it's like it's running right now.
I think I'll just straight up this down here for a second.
I can feel the anticipation in the room. Do we have an Atlas? Congratulations.
One more.
So come and see Sachi at the end and to collect your valuable swag. Okay,
One
we'll do one more. Okay, we have a Steve Hunt. Oh, very convenient. So yeah, hope you folks enjoyed tonight, and wanted to thank you for coming, because I know there's so many generative AI meetups coming. So thanks for choosing us. If you like the content, we run this meetup twice a month, once in San Francisco, once in the South Bay. And the next one is actually next week in San Francisco at the GitHub headquarters. So check out the details, sign up online via the Luma event page. So just a few more announcements before we wrap up. You might have been sitting there thinking, I've got a really cool story to tell myself. We're always looking for new speakers. If you're interested in taking part in the event, then get in touch with us. You can, if you connect with me via LinkedIn, you can send me a message there, send me a message via email, and we can set you up and arrange something. Yeah, so enjoy the food, you know, do some networking, and thanks so much for coming.
Actually, we're very impressed with technology, so I'm just going to ask them, like, how did you like adapt different maybe rapid behaviors? What does technology kind of get it?
And actually,
Steph, how do you turn this off?
Yeah, so